All right, you guys ready? Okay, good afternoon, my fellow KDE fan. My name is Ariya, and the next 1.5 hours I'll try to sell some stuff to you, mainly about web technologies and graphics and such. So I have to admit, it's very scary to be here, especially have to deliver the last two talks. First of all, I'm standing here between you and your dinner, your flight, your home sweet home, your couch, your flat screen TV, and whatnot. So I can understand if you just want to fan your frustration to me. I'll give you some slack. On the other hand, this is the closing talk, so I don't want for the next 1 year until the next KDE, next Camp KDE. If someone asks you how's Camp KDE, oh, it was fantastic until the last dude shows up on the stage, and then ruins everything. So I can't promise anything, but I'll try my best, and I'll make this as painless and as quick as possible. So my name is Ariya. I work for Sencha. So before I joined Sencha, I was working for Protect, Nokia, and then spent some time at Qualcomm, and have done some open source contribution mainly on the Qt, KDE, and WebKit project. So you're going to see some of the stuff that I've done there. Right now, I work for Sencha. Sencha is a startup company in Redwood City, focusing on web technologies. Some of you have asked me what Sencha is doing. You get to see some of our products and some of our projects here. Hopefully, that will interest you. So the idea behind this talk is basically when I talk to a lot of web developers and then present my Qt-based cross-platform apps, they always wonder like how the heck you can write apps for 3 platforms. Do you understand Objective-C, which I prefer to call Subjective-C because it's really polarizing language? And do you know do you memorize MSDN and then understand all GDI mess? And do you really write or understand the export protocol? So it's really, there's a gap between what web developer thinks the application native developers do, and the other way around, because we think that, oh, you write website, it means that you open a notepad and then a browser, right? And then you write some random CSS, JavaScript, whatsoever. That's not the case. I mean, no self-respected web apps developer these days use text editor to write raw stuff. It's just not going to be scalable at all. So the goal of this talk is to give you an understanding of what are the hot web technologies these days and the futures, and how can we sort of leverage this for your upcoming futures, money-making Qt apps or KDE apps. So WebKit is just everywhere, unless you haven't noticed it. Anyone here use WebKit-based browser? Android? Right, text-based browser? It's very popular. So even if you don't realize it, you use it. You have an Android phone, you use WebKit-based browser. You have a Symbian phone, same case. And soon Migo, WebOS from Palm, as well as iPhone. Yeah. And it's also deployed in some of the runtimes like Adobe Air. Adobe Air is kind of weird name because Air stands for Adobe Integrated Runtime. So Adobe Air is Adobe Integrated Runtime. And Qt itself, we know that WebKit has been integrated with Qt since ages. So yeah, it's everywhere. So the way WebKit project is organized is the mission is to become sort of the de facto implementation of all the latest web standard. So if you see the history of WebKit, it's been almost 10 years. I think end of this year, during the autumn, it will be 10 years. It will be a very hot anniversary. So we see from the day Apple forked HTML until now, the speed is just amazing. And you see along the line, there's release Safari, WebKit adopted by Symbian X60, Qt have it, and then there's iPhone release as well. More and more devices, Android, WebOS, and Google Chrome, and who knows who's going to announce any WebKit-based product in the next coming months. So right now we reached the peak of 2,000 commits per month. So it's a fast-moving project. Just like Tiago said, Qt might want to adopt the model that is used for developing in WebKit. I'll try to elaborate a little bit about that. So I think web rendering engine is a monumental task. That's why tests is very important. So if you check out the code, the code is actually very small. This right by over here. The rest is just the test. So there's this this quote that WebKit is basically a bunch of tests. The code is there to make the test pass. So that's why that's a very extensive.
It's so good.
That's
Sorry.
That's a very test-based or test-driven culture there. So these are the two, like, very important rules to follow. Every commit needs to be reviewed. You can't just go ahead and then break something. And broken commit must be reverted because you want the state of the code to be as fresh as possible. Like they said, somewhere in the trunk, which has double meaning. So this implies that the first step is to ensure the quality control. The second is to ensure that we don't have regression. So the second rule is only for disaster management. Hopefully you won't need to do it. And sometimes it happens. And if you see the social structure, so anyone can just send patches to WebKit as the community, and then basically you become a contributor. So random guy from the street knows how to program HTML and then create a patch, accept it, that's fine. So if you keep posting more patches and it's a good patch, it gets reviewed up to 20 patches, you can be nominated as a committer. So committer has a double meaning as well. It means that you have now direct access to the repository. You can check in any patch. But it's also, it does mean that you commit to WebKit project. So you know how it works, you trust the process, you don't become like a crazy guy that removes all tests. So right now we have over 130 committers, so it's very big project. And then if you finally contribute more, total 100 patches, then you can be nominated as reviewer. And reviewer means that right now you have the power or the karma to give some feedback on the patches and so on. So being a committer doesn't mean that you just can go ahead and post something, because if you go back to the previous slide, every patch needs to be reviewed. Even I'm a WebKit reviewer. If I create a patch, some other WebKit reviewer needs to review it. So that's some sort of social structure. And we have around 80 reviewers right now. Reviewers correspond to expertise distribution. So this is from last year, so I need to update it for this year. As you can see, Apple basically holds the major reviewers. Makes sense. They have been working for this for the last almost 9 years, and then Google is catching up pretty fast, and we have RIM and Nokia. RIM is mainly because of the acquisition of Torch Mobile, and Nokia is also because of Qt. So, and a bunch of random guys, that including me. So that WebKit is a very complex project. So there's different components. You can split it mostly into web core and JavaScript core. JavaScript core is the JavaScript engine. This is also there's some KDE heritage there because it's from KJS. Web core is from KHTML, and DOM deals with the document object model. CSS shows how this document object displayed, and there's the HTML that you might already know. Rendering part, and also SVG, very important for factor graphics and for the future. So everything is compiled together and becomes a WebKit library. So it's a huge project. The way WebKit works is there's no one alternative compile time option. So when you build it, you have to specify, are you going to build for Mac only? Are you going to build for Qt? In that case, you need Qt library. Are you going to build for Windows only, and such? So all these major components here, they're abstractions. So it's like an interface, you have to implement it. If you create a new WebKit port, you have to write your network stack or glue it to whatever network stack you have, and graphics and so on. The next example will give a better understanding. So, for example, the Mac WebKit ports, they just glue the graphics context class, which is the abstract interface, almost abstract to core graphics, the graphics stack on Mac. On Chromium, they use Kia. On Qt, obviously, it goes to QPainter. And GTK, they use Cairo and so on. So this is just an illustration of how to implement graphics in WebKit. So all the WebKit does all the processing from DOM parsing until rendering, says that, hey, there's this gradient around here. It doesn't know at all how to draw that, so you have to deliver it to the underlying graphics stack. Feel free if you have any questions. Just interrupt me. So a lot of questions asked to me is, yeah, it's a fun project, but how do I compile and then run it? So normally you don't do this, but just to give an understanding that it's not that difficult. So you have to use Git. You can use Subversion, but Git is preferable. Be careful because you will have a 1.2 gigabyte of .git repo. Remember, 80% of this are just tasks. And the way it works is you cannot just like, hey, I just want to check out like SVG, because that's just not going to work, and you have to maintain the zero regression policy. So 2 lines of code, you get the code. You may want to wait like a few hours, and then you run the script. So obviously there are some dependency that needs to be fulfilled, but this is just standard. Like you need to have compiler, you need to have Perl and such. So this 1 line of command already builds WebKit for you. Again, you need to wait forever because it's a huge project. Especially if you build in debug mode, linking takes ages because it links several gigabytes of object files. So don't do this on your notebook. And then launch it. So every WebKit port usually comes with a simple minimalistic browser, just for tests. This one, so it's just simple shell. It doesn't do a lot of browser magic like autocomplete and add log, whatever, but it's kind of works. So you can even get all the features like autocomplete. So this is WebKit built by setting the target as secure. So if you just want to use it, you don't want to spend hours, you don't want to spend gigabyte of space, you just can say link to QtWebKit. It's very easy. So with 3 lines of code, you'll be able to display Camcade websites. And if you want to use it in a widgetless mode, so you don't need WebView, you don't want to build a browser, then you can just get the frame. There's a image and there's a page there which has the main frame. So you create your buffer, which is basically QImage, open a painter, get your web page, and then render it to your image, and then you can save it. So all these lines already captures the web page. So a complete example can be seen on that link. I'll post these slides later on, so you don't need to memorize those. You can also build the SVG rasterizer out of it. So for example, the right side is the PNG rendered using QWeb page, and the left side is if those PNGs or this PNGs is open with Inkscapes. So in this example, I used the famous tiger head, not Tiger Woods, they're different. And yeah, as you can see, WebKit produces a very faithful rasterization of SVG. Or you can build some tools like, hey, why don't you search something, then as you populate the list with Google hits, then it actually fetch the thumbnail. So I created this example ages ago. Right now, if you open Google, it automatically, or it can show the thumbnail. So, whereas in this example, it's actually fetch every links and that hits and then create a thumbnail out of it. So yeah, web technologies is fantastic, but what if you have sort of large investment in whatever code that you have? What if you're discussing with the consultant, hey, I have already a big, huge C++ library, but I want to, at the same time, adopt all the craziness in the web technologies. So the solution is to build a hybrid application, and QtWebKit is perfectly designed for this. So if you, for example, already have a bunch of QObject, then you can just make it appear in the web page by calling this function, add to JavaScript window object. Window object is standard in every web page, so you already have window object, which has like the location. You can access all the DOMs, you can access everything. And by putting this, essentially you expose your QObject, and then it can access all the public functions, object properties, child objects, and those objects. So it's very easy, as long as you build it with QObject. So, okay, that's how you expose your native object to the web world. But what if you want to do it the other way around? So you use web framework, it does something, and then you want to bring it back to the C++ world, right? So you can do it using, oh, hold on. You can use evaluate JavaScript. Given the code, the string there is basically JavaScript code. It will execute it, and whatever the outcome is, give it back to you. You may or may not want to use QVariant. So QVariant is just key value pair. It's also QVariant map, obviously, and JavaScript objects, they are typically just key values. So who is really familiar, expert with JavaScript here? Nobody? I'm the wrong group probably. And by exposing the object, you actually can use a signal slot. And this is very powerful because you build your key object. Hey, something happens that you want to change the UI, which is built on the HTML and CSS. So all you have to do is like this. That's your key object. This is your signal, and then connect it to the JavaScript functions. So this is like bridging the two different worlds. And then the other variant, if you use JavaScript, you know that you can basically invoke any function with the other object as the output. This is needed if you have some sort of object-oriented approach in your JavaScript. Jeff, you should understand JavaScript, right?
Yeah.
At least there's one guy that will understand what I'm rambling here.
You should a rice in the hand. Yeah,
so there are also other bridging solutions, like given in this example from Noam, from QtNokia, like how to pull the image, where the image comes from the resource. So basically, create your own custom network protocol using QNetwork Access Manager. Talk to Tiago if you want to know how to do it. So, for example, if you ever use Qt resource, you can access everything using the QRC protocol, right? So basically, you have the choice to invent your own protocol, and then you can serve whatever the web page needs to consume. What about deployment? One of the misunderstandings then, oh, right, I want to create a web apps, but what if the user is not connected to the internet? Well, that's like 5 years ago. Today's every major browser supports storage. You can have cache manifest. You can even have a fancy synchronization, so you work offline, and the application detects, hey, there's a network connection. You just synchronize it. If you ever use Google Docs, Google Mail, actually it works without internet connection. Packaging is also an issue because right now we don't have a proper solution like one click. I create a QtWebKit based apps using the hybrid approach, and there's one click button like deploy, and then suddenly you build your apps. So we're still missing that. I hope Nokia will try to address that in the near future because that's really needed. That's one of the beauty of working with Adobe Air or Absolute or Titanium. It's a similar approach, but they have already simplified all the deployment process. So some of the technologies that I want to show here, so it's basically a parrot of web technologies, are really coming to major browser. So some of them are already available if you use, say, any WebKit-based browser. Let me just show you. So the key technologies is HTML5, like my T-shirt says, and the other logo is basically CSS3 and SVG. So if you haven't heard about or haven't mastered JavaScript yet, these are 3 books that I suggest. I have no affiliation whatsoever with those guys, but they are good books. And problem with JavaScript is people usually learn it the hard way and sort of grow some bad habits because, hey, open text editor and then write something, oh, it works, then you understand how it works. So the barrier is low, that's why it's easy to become your self-proclaimed JavaScript ninja with tons of bad habits. So this book really helps to get rid of all those bad habits. I wish we have the same counterpart like Qt, the good parts.
Well, you can use all of Qt. Well,
hopefully.
Exaggeration.
I've been there.
He wants to kill me now.
So if you develop web apps, nobody write raw JavaScript anymore because it's just so time-consuming and cumbersome. So people use these frameworks. There are EXJS, jQuery, Sproutcore, Dojo, YUI, WooTools. Sencha, one of the Sencha's products is EXJS. Even KD website use jQuery. So this is sort of like Qt, but for webs. Contains a lot of abstraction and convenient function classes, objects, and so on. So you don't need to learn. It's different if you do event handler in IE versus, I don't know, WebKit. So vector graphics. This is also a Sencha Labs project. So this is basically called Profile. It's a JavaScript vector library, and it's really good dark projection, but yeah, hopefully you can see. So it shows current time, which means I still have a few minutes. It's built using JavaScript, but you don't need to write, hey, I want to draw like this and so on. So if you see the source code, it's very declarative. You write there's this path or arc, it goes this way. There's even handling, timing, animation, and so on. So yeah. Canvas-based games. I'll show it later. I don't think I have this project. So Canvas is HTML technology for both pixel manipulation and drawing, comparable to QPainter, but you have different set of API. So I argue that in the future, maybe it's better if you write your games or whatever, casual games like Space Invader in Canvas, because now you can say, hey, open this URL and play it in your browser, or you can just wrap it in QtWebKit and then ship it as native apps, right, for different platforms, including mobile devices. Visualization, if you need some visualization like, hey, I want to know how big is the space taken by my hard drive. This is also a Sencha Labs project, by the way. This is visualizing the size of Google Chrome, the object file, if I'm not mistaken. So WebKit is 5.4 megabyte, and if you click there, it divides it. You can go deeper, and then, oh, rendering is 780K, and then you can move forward. So obviously, this is depending on the data that you give, right? I mean, this visualization just consumes the set of data with a JSON, JavaScript object notation. You could totally create a different data to be consumed, like I mentioned before, the space utilization of the hard drive. And it's really easy because you don't need to deal with all the how to draw this and that, so you just need to use it. CSS animation. How many of you have ever seen cool CSS3 animation demos? There are like tons of them, and let me just show you once. What did you see? Oh.
I don't know, you showed me when I was in your office.
Oh, this is way cooler.
Things has happened.
So this is created by Mozilla folks in preparation for that Mozilla release. CSS3 animation allows you to create animation, surprise, without writing any code. So you don't even need to write any JavaScript. It's all keyframe based. You say, if you ever develop Flash, it's exactly like that. So at this time, you have this and this and this, and then you move around. So for example, if I click on our blue planet, then what happens is all this animation. None of this requires any coding at all. So you can, including the distance visualization. And of course, writing all this CSS keyframe by hand is just tedious. So at Sencha, we developed a product called Sencha Animator that simplifies the process of creating the animation. So yeah, Sencha Animator is written in ext.js, obviously. For example, if you see this is one of the example projects. You can see that like advertisement for car rental agency called Carts, and then this is when I play this. So all this defines the object on all the keyframe ones. So you don't need to write by hand. You just need to click on this, tweak it around, create your own timeline, whatnot. Very visual, no coding needed. And then when you're ready, you just export it. It's there. So there's some cool Sencha Animator demo, I believe.
That's open source now too?
This one is not open source, but it's doesn't cost you anything. So it can create a lot of animation that is useful for education. So to create like this, usually it's very tedious, but using this tool, hey, you just need to export it, and that's it. Must be attractive for teachers and lecturers. or you can even have effects like, I don't want to make you hungry, but yeah, this is what I'm doing. You can even see all this. So accelerated composition denotes the use of graphics processor unit in WebKit. Basically, when you design all the CSS animation, it transforms the web page into some sort of scenes, so it works in a more or less scene graph mode. Instead of drawing everything, all the planets one by one, basically it just puts, hey, this planet, put it in GPU texture, then when it moves around, zoom in, zoom out, it just tells the GPU, hey, this is the new transformation matrix for this planet. So it's very efficient. It doesn't cost the CPU to do a lot of pixel processing, and obviously everything, all the transformation magic and so on, that can be handled in any modern GPU pretty easily. So again, one of the misconceptions, if I want to write Qt, I can use OpenGL, I can benefit from hardware expression. What about web? This is the answer. Use CSS animation. Even on devices like the upcoming RIM Playbook, and then Apple iPhone, and then the next Android, all the CSS animation will be hardware extracted. So it makes it easy to create a very fluid and smooth user interface. This is Saint Animator, you've seen this. Device access. So more and more browser vendors give you an API, JavaScript API, to access the various device information. So let me give you one of this. So as you see, this is running in a browser. I have to run it in Chrome because the binding is not ready yet for QtWebKit, but you get the idea. So combining with a little bit of physics engine, you can see. But this doesn't show any device API, but now if I do this, you can see that. Because why? Because it exposes the accelerometer values of this MacBook Pro. Now you know why I use this laptop for demo. Then
you actually get the video projector to work too. What?
So yeah, and this is all using CSS effect. So the ball is actually just a box with borders on all corners. So the box is like 1 pixel. Why do I open Twitter? Maybe that's the next demo. WebGL. Anyone have ever seen WebGL demo? Which one?
The human body one.
Human body?
Yeah.
Quake? Anyone have ever seen? Let me try. WebGL. So this likes Marble, but implemented in pure web technology, so you can zoom in, zoom out. Yeah. It's all running in the browser. Again, QtWebKit support for WebGL has been broken for a few weeks. That's why I have to show it in Chrome. What about Aquarium? That's usually the very famous one. Running at 60 frames per second. And so WebGL is a set of JavaScript binding to OpenGLES. If you know how to program OpenGLES, you will be very familiar with this. And you can actually change the view. Put more fish. So regardless of the number of fish, it's smooth as butter, 60 frames per second, or sometimes it goes down. I think there's a Easter egg somewhere. Oh yeah, you can see this red line is laser. There's also jellyfish, which is extremely cool. Again, this is all running in browser, simple collection of OpenGLES shader, and hey, you got something. There's also OpenGL collection. If you're into cars, fast cars, then So a lot of cool stuff you can run in the browser right now. Again, if you write games, why don't you just write WebGL and then package it with, say, upcoming version of QtWebKit, and you can deliver it as native apps, or let the user run it in the browser. Or make it the next plasma. Oh yeah, one of the Sencha Labs project again. I think now you get the idea what Sencha is doing. All this cool OpenGLs. So this is a temperature visualization from several hundred years ago, using the data from NASA or something. You can see the global warming. Temperatures increasing. And you can really zoom in and then rotate it. Super smooth, super fast. But this is not my favorite. My favorite is this one. It's playing an video, and what you see on the right side is a 3D histogram of the colors. So you see, it's taking every pixel in the video and sample it and then plot it on this. So if you see it's reddish, then you see more pastel colors there. I think in the beginning, and this is actually my video, by the way. The beginning, see, it's green, so it's green blob over there. And this is all running in real time. For education purposes, parametric equation might be interesting. So you can just type whatever equation you like, and then it produces a 3D plot in the grid mode.
Do it just lose audio.
I think your mic just died.
It's flashing and it's low value.
Is it?
Yeah, your
Under right.
mic. Oh, I thought I was on.
Oh. Well, can I just keep talking? Or?
Yeah, I guess.
Should we
Speak louder, maybe?
Right, so how do we develop web applications? So that's something that web apps needs to catch up with native apps. We have Red ID for Qt, QtWebKit, KDevelop, and others. But unfortunately, the web apps from is not as cool as what we have in the native world. So there are some development already in that field. If you want debug stuff, then use Web Inspector. This is built into WebKit. If you ever use Firebug, it's essentially the same Firebug for WebKit. This allows you to see your HTML content, networks, requests, replies. You can even profile your JavaScript and whatnot. So a lot of good stuff there. You can also dump your own network. This is easy using QNetwork Access Manager. I'm sure Thiago can do it in a few minutes. What about regression testing? Because we know already all the great testing framework, especially Qt, KDE, and so on. So, however, on web development, this is not yet very widespread. More or less because usually when people develop web apps, you need to test it in a different browser. Even same browser like Chrome or Safari, you need to test in different versions. And if you multiply the combination, it becomes some billions. And quick mode and whatnot. So it's important to find out how to do this. Some people already develop command line tools for this. So I don't know, anyone ever use Git pre-commit hook? So Git, yeah, Thiago again. Git pre-commit hook basically allows you to run some checks before you do Git commit. So the commit will be blocked or not committed if when you run the test, or when it runs the test automatically for you, it finds some errors. And that's exactly what happens here. So if there's an error, you try to commit it, it's blocked. And obviously in the native world, it's very easy because it's native. On the web world, basically what you have to do is to create a headless version of WebKit. I developed this project called Phantom.js, very popular among web apps and front-end developers for testing. This allows you to not opening any browser when you test your apps. So you just run some commands and so on. So for example, it's also useful for site scraping. These few lines of code basically find all the pizza in New York and then dump the address and telephone numbers. Again, JavaScript API. and QtWebKit. Again, another field is on native apps. We have Qt Designer for designing UI. On the web front, people think, oh, I need to put a div here and then create a button, radio box, and so on. That's not true, because you can totally use what you see, what you get. GUI designer, for example, Sencha has Sencha Designer. That if you see the interface, looks pretty close to any normal UI designer. So you get a bunch of widgets that you can drag and drop, put it there, layout, whatever, create an event, write code, and so on. So no need to try to lay out everything, and then it's like in the old days, right? KDE 2 or even before, where you have to fight to make sure that your dialog looks really good. Right now, just use Qt Designer and you're done. What about IDE? Because this is a web world, people tend to use web-based IDE. So there are some development on that front. For example, this is running in the browser, and yeah, you have an editor, you have the code browser here, you can edit some stuff and then even run it. So that's the beauty, because you run it right in the runtime itself, you edit something, launch, so there's no compile cycle. Makes it easy to have a very productive environment. There's also Cloud9, I believe. Must be somewhere the demo site, but yeah, you can check the link yourself later. And record and replay are something that we were doing at Sencha. Hopefully, we can release this patch very soon. So the idea is, if you have a web page like this and you want to know, hey, what happens during rendering? Why this pixel is wrong, or why this div is 1 pixel off? So the slider is the time. If you move back and forth, essentially, you just you freeze the time and you go back in time and see how the page was displayed exactly at that time. So it's still in the cooking, and hopefully we release this tool sometime soon. Again, this is based on QtWebKit. So all I can say is that right now there's a lot of great web technologies out there. It's very important if we can leverage for our next version of Qt apps or KDE. And there are things that needs to be fixed there, like the hybrid approach, tools, and stuff like that. And in the future, we will have more binding, so you can even access the camera, accelerometer, everything, especially with all the Qt mobility project. And hopefully, we can have first-class productivity tools as smooth and as productive that we have in the native world, and more like cloud-based solutions. Say you have you want to create a new Plasmoid, and then you use on cloud, and then you write the code and share it with others. No installation needed. Just click the link that Frank sends you, and then hey, you got that brand new and shiny cool Plasmoid. That's it. Thank you very much.
Take a 5-minute break, and then.
I have one question.
Sorry. Sorry. Just figured right at that time the schedule. Yeah, go for it.
You showed us massive, very impressive, great examples of how you can do everything in the web. So where do you see the place for KDE in this world?
My question.
Well, all the same question.
In a browser.
Leverage it as a new set of technologies. So, for example, you can maybe John can develop Cartographer in WebGL or improve Marble, so that both the native apps and you can provide the web-based solutions. And I think it will. I mean, you want to ask that question, but I'm sure in your mind you have some ideas on how to connect this to OnCloud, right?
Sure, but I want to know what you think.
Yeah, that's basically what I think. It's very important. Web technologies are the new trend, and then there's very important development there. A lot of big companies put a lot of effort there, and it's just too pity if we just bypass it and sort of skip it. And everything from Canvas, new SVG comes from KDE as well. There's a lot of KDE heritage in WebKit, KXML, KSVG, KJS. maybe many other modes. And it seems that it's a good opportunity for us to, hey, there's this set of applications, let's just use it. Use the CSS3 animation to help our designer create a fluid usage or something. So it's very easy. Right now, I don't know what tools people use to develop native fluid. There's probably none. You have to just like play by hand, and then it looks good. But yeah, what you see is what you get. Live demo running, and then you can manipulate the keyframe. I'm sure the designer will love it. Go ahead.
A few weeks ago, I started to write my own presentation program with QML, as a lot of people, I think. And then I realized, is this really the way to go, or should I do it in HTML5? I mean,
if you ask me, I'm biased. I would say HTML5. But
I mean, do you think that the QML idea is somehow?
I will just say
similar to HTML5.
It has its places.
Yeah.
So, but once you move outside all this casual Flickr type of application, you want to leverage all the great JavaScript library and frameworks out there. It's kind of difficult because it's not a standard JavaScript one. You need to right now, for example, Nokia develops a set of components because you need to rebuild again all the widget sets. Whereas if you just leverage whatever EXTJS, jQuery, and others provide, then you start not from scratch, but from something that already exists. And if you do it properly, if you know JavaScript really well, it's not important. It's not difficult to write apps that can use both technologies. You just need to abstract it properly, and then you add a proper glue. Some people are not big fan of this because it's just adding more wrapper to the wrapper. But if you have to live with two different set of technologies, then maybe. So there are things that QML is really good at, like graphics acceleration and that kind of stuff. But I see that WebKit's also catching up. Yes.
What's HTML5 bad about? Because I'm told that it's still limited regarding how you can make your application.
HTML5 what? The state?
Both the standard and how you can make really nice flowing applications.
It depends on your type of applications, because people develop like millions of apps, and on mobile device, more and more people get rid of the idea of learning Objective-C to write apps for Apple platform, Java to write apps for Android, and then C++ to write apps for some other platform, and just put it there.
But I talk about technical merit and not about market share.
I think it's moving really fast and it's in a good state. I don't know who says that it's not capable to produce.
It's the other argument is that the phone has limited CPU power, memory, and other things, which is a technical property.
Yes, it's inherent to that, because if you use WebKit, then obviously it requires more power. But again, engineering is about compromise. So do you want to use that power for that, or do you prefer to squeeze every juice that the phone has and then requires only 64K of memory?
Because I have this kind of little bit, because KD has the ambition to be on mobile devices and such, and then you get into a price point where everything counts. You know, every nickel you can squeeze out of getting cheaper memory. Maybe, oh, I cut performance on the memory bandwidth with 50%. Oh, I didn't see that WebKit needed more.
I think one of the good examples is the HP/Palm WebOS, because their entire stack is based on WebKit, and because it's shared among all apps, then its package is kind of diminished if you divide by the number of apps. So it's kind of amortized itself, because the entire stack is essentially WebKit.
Yeah,
Last one?
Yeah, just one last question. I hear a lot of people getting very excited about JavaScript engines. I was wondering if in your block diagram, the JavaScript engine was its own little thing. I was wondering if is it possible to experiment with replacing with things like V8 or whatever the hot flavor of the day is, or whether that's a reasonable thing to try at all.
You can experiment with the JavaScript as is, like standalone. That's really possible. It's really easy to build JavaScript core SpiderMonkey or V8 and then write something on top of that. I've done a lot of stuff in that front. And with respect to changing it, I think QtWebKit has an experimental branch right now where it uses V8 as opposed to JavaScript core. But V8 is being fixed because WebKit is not thread safe. That's like one argument against using WebKit. And then there's another counter argument, just use split process. On the other side, V8 is not thread safe, has a lot of static variables, but they're going to fix it. I mean, using V8 as a backend for QtScript and make it QtScript non-thread safe is a regression. That's why Nokia Fox can't use it. And there are other things that I'm not supposed to say here. Okay, thank you so much.